Good morning, Mr. Taka.
Morning, Gabriel. How are you?
Fine.
How is it?
It's fine.
You said you are in Arusha.
Yes, I'm living in Arusha, but now I'm in work.
You are in what?
Mbeya City. I'm at work in Mbeya. But
There. How far is it from Dar es Salaam?
like 500 kilometers.
My friend.
It's very
That's
far. Yeah, it's very far. I think it's more than 500.
I was telling people to save their work on the drive if they are printed, so I can be able to check it. Yes, Rama. Can you be talking?
Yes, we can talk.
You talk.
What am I trying yesterday to do this fire system and socket, and yes, to make this calculation for lighting, but I'm not finalizing the lighting at all. But I make the socket and the fire.
But I'm seeing fire alarm in one room, socket in another room, light in another room.
That's what I'm doing.
Why? These are different floors. This is a three level.
I know. You know the issue is what I don't know what can I say. So what I'm trying to do in each floor, but to do because you know I have hardness for understanding. That's why I just to touch in everywhere.
Why didn't you do fire for everywhere, power for everywhere, and light for everywhere?
I think once I practice, I can do it slowly, or maybe I can do all.
Because each subsystem has its own drawing. There is a drawing called power. You know the way you have assignment 3-story building. We have something which is called power 3-story building. You have a file called.
Yeah, I know. I supposed to make the. I supposed to make all drawing from ground to second floor for power, for light, and for the fire. But you know, because I missed for these 2 days. So what I'm trying yesterday, just to try in each floor. But slowly, I'm going to make it.
Yeah, I could prefer if you could have done power, light, and fire alarm for one floor only, than doing light for ground floor, power for first floor, and maybe fire for second floor.
Yeah.
Sorry.
Yes, that's what I'm doing. But I can do for all. But because of the time, I will not manage it. But maybe for future,
What I'm telling you, focus on one floor. Do light, power, and fire for ground floor first.
Okay.
And we are not putting fire alarm in the toilet. I don't know we are putting smoke detectors in the toilet.
Okay, I'll take it out.
Why am I seeing 4 plants?
It's not allowed to put the smoke detector on the toilet.
I'm seeing 4 plants. Can you zoom out? Zoom out. Zoom out. Zoom out. My friend, zoom out.
You see?
Zoom out. Zoom. To zoom out is to reduce the zoom, not to increase. I'm saying, why am I seeing 4 plants? I'm saying 1, 2, 3, 4.
This one just I made the calculation for the lightings to know number of lighting. This is because here this for this ground floor. So yesterday I finalize the calculation, then I'm going to put the lightings.
Can you click on that bed in the bedroom? Can you click on it? In a random room, can you click on the bed? Bed.
This here.
Click on the bed. Bed. Kitanda. My friend, did you attach? You have worked from the file I shared.
You know, I have problem of attaching since day one. I told you when I attach, I fail to exploit. So what I decided to work on.
I said exploding is not necessary. You could have kept it with the color. Did you succeed to explode now? I
failed it to exploit.
But that was not the priority. The priority was to learn how to attach, not to explode.
To attach I will manage, but to exploit I was failed.
That's what I'm telling you. You could have just attached it as it is, because this is not an attachment. You have worked from the file I've given to you. You didn't attach.
Because I was failed to exploit, so it's difficult.
That's what I'm telling you. The priority was to attach, not to explode. You could have attached and keep the file with colors like they were.
And I can work from there. Okay, let me do that for the lighting for only one floor. Lighting, power, and the socket.
I still need to see your screen. Why do you stop to present?
No. What I want to do what you tell me to do. So I want to attach.
Present once more, my friend.
Huh?
Present your screen, my friend. So use the file below where you have the calculations for lighting, and get another floor plan for ground floor and put there fire alarm. You can refer to what I did. I've already shared my work for power and fire alarm. You can refer on that to do the fire alarm also.
So you want to tell me like more to work on the attached file? Because me I need to work on the attached file.
Apart from this one, we don't have time.
So you allow me to proceed with this one.
Copy that full plan, put it aside, put fire alarm there, and proceed. Ground floor. For finish light, you can refer to what Lookman did yesterday. For fire, you can refer to my file. I've shared them in the drive this morning. If you can check in the email, then make sure you also have the object. Did you also fail to copy them, to put them here?
For the file you share?
I'm saying the objects, the other symbols.
Oh, yes, I have this problem of taking the object from the other file to this file. So what I'm doing, just I make the symbol that I'm using to make the drawings. But yesterday I take a lot of time just to learn through the video shared from Engineer David, that I get some small idea. So hope slowly I'm going to catch it.
Yeah. Hope you'll go through. Okay. Did you understand what I told you to do? Copy the full ground floor, put it somewhere, and put file alarm there.
Yeah, that's what I want to do now.
Yeah, so we are going to see the progress of one of our fellow friend who has gone far for life. We are going to use his work as a reference so we can save time. A kind reminder for everyone who has not yet submit the survey. If you have any issue, please raise it now so you can do it. Otherwise, you will not get certificate today.
Mr. Taka, what did you say?
Please fill the survey in the group. Otherwise, you will not get certificate.
Okay.
Boss, did you submit the survey?
Hey, Mr. Gabriel Iyimo, have you not yet done the survey?
I've not done the survey.
So I'm giving you 20 minutes from now. Go to the
Okay.
group. There's a video that shows that I shared yesterday, a YouTube video that shows how you can do the whole survey. It's very self-explanatory. And then you click to survey, you fill in all the information. If no one have, this is just a grace period. 20 minutes from now, and then because he has to get to Autodesk office headquarters so that they may certify you. Do you hear me?
Okay, thank you.
Yes, a quick reminder to everyone. Maybe Mr. Taka can also help me emphasize to those who are there physically so that we make sure that no one loses their certificate. Thank you very much.
Did you submit your survey? And you? And you? Sorry? Did you submit? Why? Yeah, David, I have 4 people now who are in the class. A 5th one is coming. Some of them were not yet ready with the survey. They're filling it now. Or did you submit your survey? Sorry? Not yet. Can you do it now?
Let's give them 15 minutes for it, just particularly for it, because it's very urgent.
But can you check if people who are not here have also done it? So the people who have done it is what's your name is? Bryson? Or David? Are you able to check people who have submitted?
No, Mr. Taka, it's very easy. If someone has done the survey, they know themselves. Until you reach, until you reach to the last step. If they have not met the survey, it's on them. They will not receive the certificate.
Yeah, because there are 2 people who are not here, and I don't know if they have done it.
Can you tell me their names so that I can check up with them?
There are 2 guys who are not here. What is their name? Boss, your friend is called? The other guy? Sorry? Abedi. Can you check Abedi, David?
Yes, Abed and who? And Emmanuel.
And this guy is called? Gelvas
James.
Yes, and Abedi.
Okay. Perfect.
Boss, please work. We have a lot of stuff to do. Please focus on your work. Unless you are done, please focus on your work. Gabriel, is there any issue or something you want me to help you with? And Rama, please, this is the right time to ask questions. Can you share your screen, Gabriel? I want to see your work progress. Understand? Finish, my friend. You need to do that like if someone has an issue, this is the right time to ask it. In the few next hours, we'll be doing some final touch. Yes, good. Can you speak? I want to hear you.
I've just make the fire alarm symbols in all flows. Hello?
Can hear you.
Yeah.
Did you print everything you should have printed? So same with power.
Oh. Let me print now.
You want to print? Is your drawing set up? Did you arrange all the title blocks and everything for you to print?
For making for inserting title block in the layout has become very difficult to me.
You did yesterday.
Yeah, in Power, I did it in Power, but
Go back
as
in
I
Power.
told you,
Show me how you printed. Save this and go for power. No, it's fine. Go for power, fine.
okay. What?
Oh, that was many power. That was many power.
There is one.
I'm saying many. Power, AutoCAD, power. Where did you print? Because you said that you succeeded to put it in power. Where is it?
I think it's not one of these. Let me go direct to. Let me go direct to. Mr. Shit. Wow.
Or if you have any question, you can ask. You finish your survey stuff.
Graphic.
Yes, if you're done print, you can print.
Alikuwa hapo kuunganisha zile kutia hizo na switch. Mouse.
Before even thinking about circuiting, each switch can be connected to the light, which is when it's connected.
Yes.
That's part before you probably think about circuiting. Okay. And you can change this color. This black is not clear. And make it blue, make it even green. I'm saying before thinking about circuiting, you can connect each switch to its respective light.
So yesterday we did the calculation for the luminaires in the room. Garage, as you can see here from the diagram. There's stairs, kitchen, bedroom, bathroom, and a studio, right, for the ground floor. So after looking for the appropriate lights, you do the calculation from the room to get the placement, and then after doing the placement, now comes the switches, the light switch. So when we're compiling this, we also compile the type of switch designated for each room. So starting from the garage, you install the fully manual. Oh. What have I done?
Sorry. I think
I lost something.
so look money only helping people who are behind. To think you are far, go to second floor, first floor, change the light. If you have any questions, any concern, the right channel to it. Because once just finish to do lighting there, we'll go for power, we'll go for load classification, in the right.
Yes.
We'll not be someone who's behind.
Yes, so for the garage, you put the full manual switch, and then you come to the dining, you put a dimming switch. This is for where you adjust the intensity. So if you want like the light to produce with full intensity, then you put it at maximum. And then if you want to reduce it, you dim it for a little bit. And then for the studio, also fully manual. This one, the C, the control. That's what we are focusing for, which type of switch to place. And then for here, bathroom, you have the sensor. So as you go in, it switches on its own, and when you leave, it switches off. And for the bedroom, you also have the dimming option. Also, maybe when you are working, or you just early evening, you can put it full intensity, and when you want to sleep, you can put it a dimming option, something like that. And here we have for the corridor also motion sensor. So also when you pass, it switches on, and as soon as you leave, it switches off. And here for the kitchen, fully manual, also control. And lastly, for the stairs, control, which is also the movement sensor. But it doesn't have to be this way. So this is just an option. You can choose according to the type of design of the building that you are doing. And suggestion from the client, maybe, or architect. After consulting, then you can decide which type of switch, appropriate switch will go in accordance to their budget. So when we go back here, so for the garage, fully manual. And you come from the legends, you have the one gang, one way switch, this one. So you move it here, to place it somewhere here to control the light in the garage. And maybe you can go for the stairs. Let me get the motion sensors. Go. Maybe motion sensor.
Should be up. Up.
Yesterday. From the Google Drive.
Oh. Go up, my friend.
Movement, right? Movement and dimming, yeah.
Mr. Lookman, we don't see your screen.
Yeah, Bishop. First, 1 second.
Okay.
So I hope people are working on their project. I want everyone on the mic.
Okay. So get the symbols here. So you have the motion sensor or movement sensor switch, and we have the dimming switch. So you just refer to this file, see where we place such kind of switch. So for this, the stairs, you need to place the movement sensor. I can go back here. Okay, movement sensor.
Lookman.
Yes.
Sorry, motion sensor and the movement sensor is the difference or the same?
The same. in that.
Yeah, let me emphasize something there. There is maybe two type of detectors that might be different. There is a fusion sensor and a movement, but motion and movement are the same. So a movement sensor means detect the movement of someone there in this person. A presence sensor detects the presence of the person. That means, for example, if you are
We are not hear you.
I think my microphone is on. You can't hear me?
No. I'm not hear you.
How do you know that? Oh, you can't hear me properly, maybe.
I hear you now.
Yeah, I was saying that there is difference between movement sensor and presence sensor. But movement sensor and motion sensor is the same. The difference between a movement sensor and a presence sensor is that a movement sensor detects an action of someone moving around, while a presence just have to make sure that you are there. It means if you install a movement sensor in a room, the time you sleep, because no one is moving, you switch off light. While a presence sensor, if it's still detecting someone there, you never switch off. So that's why in the areas where they might detect people who can still see and not in light in a room, it's better to put a movement sensor. Otherwise, it keep the lights on the whole night if you're asleep, while maybe you don't need it. And so, for example, if it's a movement sensor in the equipment, it might still be there, but it will switch off because you are spending a lot of time without moving while you sleep. But a presence sensor will keep the light on for the whole time if someone is toilet because it's detecting a person. I think that's clear.
So I place the dimming switch for the bedroom, and we put the movement sensor for the stairs here as per the diagram illustrates. So for the stairs, motion or movement sensor. For the garage, fully manual. Corridor also motion sensor or movement sensor, and bedroom dimming light, and dining hall also dimming light, and the studio fully manual. So just place your. So for these switch symbols, Mr. Tucker is shared in the WhatsApp. You can get them. You insert them as a block. And for the normal fully manual, it's here. One one-way switch. So you just place them. Then the movement also corridor, the corridor. Here. What is studio fully manual? This studio. Place it near the door, so it's easily accessible. And then there's bathroom. What does bathroom say? movement sensor also. Then what else? A bedroom already, corridor already. There's kitchen, fully manual. So kitchen, stairs, garage, dining, studio, bathroom, bedroom, corridor. Okay, I think it's all done. So for the garage, fully manual. For the stairs, movement sensor. For the corridor, also movement sensor. For the kitchen, manual. For the bedroom, dimming switch. For the bathroom, movement sensor also. Studio, fully manual. For the dining room, I haven't placed. Okay. Dining room, dimming switch. Yeah, I already placed. Okay, so everything is done for the switch.
Okay, that's very good. So what you have is to connect the switch with different outputs, like the way we use for power. Like from the switch, the first light, the
Second,
yeah. So we can know the command lines of all the lights.
so let's say start from here.
Take it from center.
From the center of the switch. Okay. Yeah. There. Okay.
How people are following and they're working on their lighting.
And the luminaire the same or just on the sides? It's fine.
Center.
So we are doing the wiring. So from the switch, we start with the garage. So you connect the wiring, you use the 3-point arc, this one. And then you have to activate this one for the snap caster, for the precision. And then you take it from here to the next light. The second light, and then you take it from there to the third light. Then reduce this one, make it smaller, like that. So what's next? You can annotate this for saying the first circuit of the light. Say lighting circuit, ground floor 01. Call it that. So you can go to layer properties and create new layer. Okay. You can say lighting annotations. Maybe put the color green. Just delete it. Okay. So for this, for the annotations, you can put under light annotations. Light annotations. And for this will remain under lighting circuit. So we'll go to the next one. Here you can say
everyone every time from the light the next one.
oh here there are two luminaires. And we do this like that. Very annotations. Say lighting L G as in ground, second one. Say come here in the kitchen, 3-point arc, start from the center, go to you can decrease this, or maybe you can say start from this.
Why is it middle? Why is it middle?
No, it's near the door.
Where is the other thing? Is the next area also a kitchen?
This one is the kitchen. This is the corridor.
Yeah, but the next light.
Next, which one?
One here.
This?
No.
This? Huh?
The other one.
This?
No.
This one. This?
This one of the.
Yeah. It's...
How is the wall there? Then that is another room. Can you check on the PDF?
Yeah.
Which area is that?
Kitchen, this one. See the boundary.
Yes.
No, there's a door there, near the door.
Yes, it's door there, but there is no.
This one.
Yes.
Okay.
So
on this side.
Put at the entrance.
Yeah.
Move it. No. Can you even move it there?
Here.
No, not behind. Where the door is closing. The area where the door is closing.
It's closing. Here.
Yes, but inside.
Okay.
Yeah. Normally it's always 20 centimeters from the door edge. Yeah, minimum.
Okay. Okay. So we move for the kitchen, use the fully manual. So we move from here, since it's in the middle of the room, there's no wall. So we put near to the door. This is the symbol for the door. Okay, so we connect the light. And here we finish the last one. Okay, so which number? 2. Combination. Light ground 3. And then we go to the bedroom. I remove this first before I put it again. Connect the bedroom, the second, and the house of this.
People online, are we together?
Yes, we
Yes.
are together.
This is the studio. Okay. Okay. Oh. this also I can move it. Okay. Put it. Okay, which one remains? Only the corridor. Okay, so it's done. So it's done.
Yeah. You want to stop sharing. So we are going to proceed with circuiting, but before that, so we talked about decorative light that can still be used or added on the drawing, on the design. So let's say if you are in the room and maybe you need can you please follow what I'm saying? I was saying that for the lighting, we just focus. We're focusing on the main light that will help us to achieve the lighting purpose of the room. But we are not excluding any plan of having a decorative light, could be in the corridor or in the living room. Or maybe you need a light above the table, or in the room, a bedroom, you need a special light for decorative purpose. For the sake of time, let's focus on making the circuit with the existing light first, and then if we get enough time, we can still come back, add more light, because it's always better also having a specific switch for that special light. So as you switch, either you switch all the lights or one type among the 2 or 3 that you are having in a room. So let's first proceed with load calculation for this light. So I'm going to make the circuit, and then trying to see if we can go for the load calculation. So I think for people who were asking about the number of lights to put in one circuit, the answer is a technical answer. It's not something that's to assume, because people allocate the circuit, or people allocate the number of lights to put on a circuit depending on the protection, calibration, and also trying not to make a very long line. I will explain it to in the idea of having shorter lines, because if you put, let's say, the entire flow on one circuit, and there is a short circuit somewhere, which is going to affect the entire flow. The entire flow will be dark. So you have to also consider that. Let's say, for example, if we are having 10 amps as the minimum or the nominal current for the protection, and if you consider working under 230 volts, it means for one circuit we can go up to around 2 kilowatts. So 2 kilowatts of light, there are too many. Even in an entire flow cannot reach that level. But it's always good to divide the entire flow to understandable circuits, so to avoid issues of voltage drop, for example, because you have long line, you'll have voltage drop. If people are doing, let's say, ring circuiting, they have to have one cable coming back to the circuit in the DB, so that will mean more cable to be used. So that's why we can just allocate circuits in different areas. So if we go back to ground floor, let me share my screen. So if you go back to ground floor, with this configuration, I might go for 3 circuits. Let's take this area, and this as one. I can take this entire area as a second circuit, and this one is the third one. Or taking the entire area here as one circuit, and this plus the one below here is the second circuit. Yeah, that could be the way I could go for it. Yeah, so let's try it and see what can we get. But with the level of power that we have of our light, I'm expecting that will be very far down compared to what you could expect in terms of power. You see, as I said, we have a nominal protection of 10 amps. But if you check some examples of other previous projects, because we are working from a template that I can share with you. So we are having situations where we have 1.3 amps, because all the lights are going for 312 watts, which is very far below the rating. But Yeah, so that's how we are going to do it. Let's have 2 circuits in each floor and see what we can get from that. I think Lukman can still proceed. Are you able to proceed? Yes, let's go for circuiting on ground floor. Yeah. I think people who are online have understood the logic of how we are going to do for
So,
lighting.
like for the sheet you displayed before, you speak about the 1.3 amps. Can you repeat? I'm not clear about why 1.3 amps.
When 1.3 amps is after dividing the total power of the circuit by the level of the voltage to know how much is crossing through.
Oh,
That's
okay. Oh, okay. So I mean, okay, understand.
we will get back to that model.
No, okay.
Coming. So you know what we're going to do? We are going to do it with dash lines. I don't know if we'll be able to do it. You can still connect with the lighting circuit layer, but we'll make it dash. So what you can do?
Yeah.
And you can only put the name close to that side. So if you select the same, you go here, go here also, you go to that, and that the entire one is more on top. You only put the name of one. You can use the line.
So
So we can use the one time
so it's going to be from the garage and maybe dining hall one circuit, right?
So we just do enough here. You do enough from enough here. from here to here. You can put it up from here to here. Yes, like that. And that's why just keep on doing that. See that, so you can, because if you put it continuously, you not know the control. So we keep continuous line to the control line, and you have that you want to do where you have sensor.
Hey. Why does it?
No, don't take it down. Just make it.
So is it gonna be the same name or a new one?
No, normally we even put the names on the surface. So here, 007, 1, 2, 3. If there are two surfaces, we have only
Two names. Okay, for this and this.
you can have one for the first surface and two second one. This is that for three surfaces, then you can do only 1, 2, 3. Can you talk?
So we're joining the lighting circuit from the garage and dining hall. So as you can see, from the garage is LG01 and from the dining hall is LG07. So we draw an arc from here to here joining this, and we're going to adjust it later to be in form of a dotted line.
No, I will say we will only keep names for surface. You don't need to name the control system. Like all those A1, 3, remove them. You only name surface. If only one surface, the entire one will be only NG1.
Okay.
There is only name control.
Okay.
So keep NG1 and delete all the other LEDs.
Yeah, like this, right?
Yes. Don't put it everywhere. Just have it only on one surface.
Yeah.
And we know that the entire surface is like
this and this.
Can we change the color of that line that connecting two circuits?
No, it's going to be the whole circuit now, from the garage to the dining hall, the whole circuit. That's why I delete the names for the ones I put before. So all of this from here to here is going to be LG1.
Yeah, we can continue. Same connect with that one. Yeah.
This and this.
Have 2 or 3 circuits.
So this whole thing now is LG2. This, all of it LG1, and this LG2. And this LG3. We have 4 circuits. LG1 from garage to dining hall, and from studio and bathroom, LG2, and then from bedroom and corridor, L4.
Okay, so please save it and put it in the book.
Okay. Okay, so I'm going to share the file.
So let's take a break for 15 minutes while people are taking breakfast here. So we resume at 10:55 or later 11. I want to see the screen of Mr. I want to see the screen of Mr. Rama.
Okay, let me share.
Look, man, prepare all the capacity of the light, the details of the watt of each light. They're taking a break up to 55 minutes. They're taking a break for tea up to 55.
I think you see my screen now. I've did the fire and socket, but now just listen what the light design going on. So after that, after finish that socket, I can start the lightings.
No. Okay.
Hello?
I can hear you. Wait. My friend, we are now working on lighting. I want you on lighting. That's why someone was explaining and he has shared his file.
What I'm saying, we just listen carefully what the Lukman teaches. So
use that file. Make it yours. I give you the permission. You don't have time. You can make it yours.
Yes, let me make.
But you have to pay copyright. Rama, you have to pay copyright.
For what? For what I did for Thimble, because what I take in only Thimble, but others I did it myself. For even when you see the design is not right.
You're now using the lighting of someone else. You have to pay copyright.
Lighting drawings.
I'm saying take the lighting drawing that Lukman has put in the group. Use it as yours.
Okay.
Manyundo, how are you? Are you back? Mr. Manyundo. Mr. Manyundo, how are you? People online, we are back. We are back. So I said people who are not able to finish the ground floor light, they can just copy the file that they have given to them. As I'm doing, I've also used the same file for reference. I'm expecting that everyone has finished his power and all the circuits are made. We are going to do the load calculation. So I'll send to you a link send you a link. I used to call it the design intent. For people who are online, I've sent you a file, design intent for load calculation, material specification, and bill of quantity. So this is mine. The screen is not shared. So I'm sharing the screen for you to be able to see the file you're going to deal with. please open it. So we'll have a part of this in one corner of the we'll have a part of it in one corner of the screen. So open the adapted sheet and even make it big. So I need your attention, please. People online, are you able to see the link I shared, please?
Yeah, we managed to, but let me maybe open again because I don't find that adapted sheet of this stolen building. Maybe let me open again.
You are seeing what?
I see the stolen building. Stolen building. After stolen building, there are single line diagram calculations, acing and the potential bondings, writing, but this adapting sheet is not found. Let me open again.
Are you able to see this sheet? Are you able to see that sheet? So this is a template that we are going to use. We are going to adapt it on our project. I've used it for previous calculations, and as we couldn't start from scratch, I just took it from there to adapt it to this project. So it is just a simple calculation for people who are familiar with Excel. So here we have just a name, electrical load estimation. Normally this is made for a specific DB, but we can still do it for the entire project. Means we will have the main DB aside and the sub DBs on each. This is the voltage between two phases. We can adapt it to Tanzanian standard. How much do you have between two phases? Sorry? 400. Okay. Sometimes 400, 410. So the voltage between the phase and neutral is 230. So feeder is MDB. MDB means main DB. Don't worry too much about that. So we do calculations for light and power, but I will explain you how we are going to do this properly. As I said, this is just a template. We are going to start from equipment up here. So just for the sake of calculations, we are going to take a single socket and give it a value of 250 watts, 250. The industrial socket that we have, we'll give it a power of 3500, which can change because it is mostly supplying a cooker. It can be for different values. And remember this, we plan to have it a 3-phase. The next item, normally all of this should be deleted or replaced because we are going to have different types of light. Let me just highlight them with a different color. So we're going to take all the equipment that we have used in the project to assess their power, so it can help us for calculations. Just don't mind about this point. We're going to delete them sometime. So the person who was asking about the double socket will be considered still the same as a normal socket. So we'll give it a rating of 250 watt also. So the AC machine, we have the AC. Mechanical engineers can give us an approximation of the rating of an AC machine. Which power? Sorry? Like this normal AC. No, we are taking an estimation. Sorry? How much? 9,000. Like this one. Okay. They consume that much. What is the repeatable manufacturer for AC systems? Guys, which brand is that one? Guys, can you read this for us, that brand? The brand of that machine, AC. Dell. Midea. This one? three phase? I'm seeing here the thing about three phase. This two phase. It's three phase. Or it's single phase. That's too high. This is the point 100 and 1000 and 200. Even now another one for 600. So there are different ranges of values. Sorry? That one is how it's affected. Sorry? Yeah. I want it in terms of power consumption. This is 1.8 kilowatts. Sorry? Which one? So, let's see. Okay. This is 4.9. Can you put that in the group? So let's go for 5 kilowatts, right? So you said the brand is called Idea. So we go for we'll go for 5 kilowatts. What about the hand dryer? It has a motor of 250 and a heating element of 2500. So that is 3K. So this is a very important process. Not doing it for just spoiling time. And I hope people understand what we are doing. So let's now go back to the lighting plan. So the lecturer will tell us how did we plan this stuff. So if we have this L linear light, 17 watts. Then we have PL02, PL02. $18. PL3 is the same. Its capacity. $15. D6. $22. kitchen. TN 01 29 watt. Then D5, let's check it. $17. Is it the same type as this? Ah, no. This is downlight of this is 17. D5. Okay, I will need those details. D5, 17 watt. So we go for calculations now. We have 4 circuits of light on ground floor. So we have 4 circuits. Please follow what I'm doing on the screen. Please follow what I'm doing on my screen. Please follow. So we have the first circuit. He has called it LG 05001. I can call it the same. I've planned for LCF1 and still take his name. So it's this one. So that circuit has how many lights in total? That light has circuit has 1, 2, 3, 4, 5, 6, 7, 8. So it has 8 lights. So if they were having same characteristics, we could have just done 8 times the capacity of the single one to get the total capacity, but we can't. So what we do here in the place of calculating the total capacity, just do equal. It's equal to 3. It's equal to 3 times the first type of light. I think there are 3. The linear light times the capacity. This one, 17. Are we following the screen, please? Plus 5 times how much? The next light is PL02. Then enter. So you have 141 watt. So the reason of calculating that way, because if we come here, let's say for example we are changing this type of light, this L1 is changing from another one, or maybe we are changing the power capacity, we can just come here. If maybe this is changing from 17 to 20, so if you update it to 20 everywhere you had that light, it will change the capacity. You see, it is now 150. So that's the reason of changing that in that way. So here we have 17. So let's go fast now. We have understood the process. Is there anyone having a question about that process? I think it's very clear. We're just doing it the way we could have done this plus this plus this, then coming here plus this, all of this. But we're just doing some some random mathematics that everyone knows. So we come for the second circuit. So the second circuit has how many lights? Yes, boss. You're asking me why am I putting them on same circuit? Because that is what we planned. That's what we planned. You see, they are on same circuit. They are linked on one same circuit. These 3 lights and these 5 lights, they are on same circuit. It's called LG01. Why? That is how we planned it. They are not on same command. This switch is switching these 3 lights. This switch is switching these lights, but they are on same circuit. They have the same supply. They are going to the same breaker. Yes. So as I was saying, this line will be that. So this line will be dashed to show that there is no command connection between these 2 points. They're only on same circuit. They have the same supply, but the command are different. So we go for the second circuit, LG02. All people who are making noise there, they are with us. So we have LG02. How many points do we have there? We have 1, 2, 3. We have 5 points.
Six point.
How many? This is a motion sensor.
Ah, okay.
Not a light. So we have this will be equal to 2 times, we are going to be equal to 3 times what? PL05 PL which is 15. Sorry. Would be 3 times this one plus 2 times G7. Let's put it here. Let's put it there. Then we put this is 6.5 watt. So down light G7. So we have the third circuit. We're having how many points? Have 2 here, 1. Have 1 here plus 3. Therefore, it's equal to 3 times D6 22 plus plus 1 times the same is the what? How is it called? D5. D5 we told me 17. Oh, this is also D7. If it's the same type of light, we can give them same description. Okay, let's call this D7. Oh, the fourth circuit is having how many lights? There are 2 here, 5. So you're having 3 times Cn01 is how much? Cn01 29 plus 2 D7. Watt. So this is the first circuit that we have on ground floor, and their rating capacity. What you'll do, come here to my file, do copy, make copy, and create yours. Remove my name, put your name. So you can also make your circuiting. I want everyone to go on his drawing. Make sure you understand these 3 lines, 4 lines. You know the capacity of the light that you have used. Make the same table as mine and your calculation. I want to see the rating capacity of the circuit. Please, everyone, for ground floor lighting.
We are not hearing.
We are not talking. Everyone is working on his lighting drawing, following the explanation I've provided. Gabriel, I want to see your screen. I want to see your table.
Okay, but I found some problem here. Let me share my screen.
Is the person online talking? I can't see anything. Is someone talking online? So let's proceed. I said that hope everyone has access to my file, the one I shared here drive. I've given you link twice today in the morning. Hope everyone is having access to it. So we are going to proceed with light with power. The person who is online is not talking. How can we help you? We don't know your issue. You are not talking. We can't know how to help you. What is the problem?
We are using the power circuit of the one which you sent.
No, we are first analyzing light. Are you done with light?
I had We are continuing with power. No.
We continue with power of the light. That's why
Okay.
it's time to finish light first. You had to make your own circuit and you go through the same process as I did for ground floor only. Did you finish?
Is my ground floor lighting circuit is this one?
Yeah, but you had also to do now calculations to know which power do you have on each circuit. That's what we were doing. Gabriel, do you understand the process?
Look, the whole circuit of the ground floor.
Yes, so each circuit you know how many lights of which capacity, then you add you just do summation.
So like this circuit which I have right now.
My friend,
Right?
I've explained it very well. Mm. You just count how many lights you have and what is their capacity, you make it total. You have D5, they are 3, you have D6, they are 4, and I'm wondering why are you using everywhere a down light while we have I've shared with you a plan of which type of light should go in which area. You did not follow it? Gabriel, I shared a plan of which type of light should be used in which area, and we have gone all through that process yesterday. Why are you not following it?
I was failing to make this new symbol.
That's why you went for one type of light.
Yes.
Where did you do calculations to know if you are using 2 or 3 lights?
Like we calculated yesterday.
Yes, we calculated based on our light. You were only using down light. You should have a different calculation from ours.
But this down light here, it's, I think I put the details of it with the one that we used yesterday.
Like it can't be D5, then you call it a linear light. Okay, it's fine. We'll catch up after. Give me a minute. Let's proceed with power.
Okay.
Hope everyone has made the circuit of power. It should have been done since yesterday. We're just going to do calculations now. Okay?
Okay.
So, stop sharing your screen, please. So we are done with light. Very simple, very clear. Everyone has understood. Unless you ask question now. You had a question, boss? Please ask your question. Yes. Sorry? Movement is a circuit. Yes. A movement sense is controlling light. Yes. Yes. So power is very simple. The way we did it. Can I get a
Yes, please. So hope everyone has met his circuit yesterday. What you're going
Just to do, we are not even discussing about the location of the DB now, even if I made it fast myself. So we have ground floor. I have 4 circuit in this. Sorry, I have 4 socket in this area. I've made that to be the first circuit. It's called, you see, I have called it PCG1. This is power circuit, ground floor, circuit 1. Hope you also have your same circuit like this. There is no need of following exactly what I did. You have your own arrangement, you have your own way of arranging your point. So I have the 4 point. I came here and name it. You see I have PCG1. There are 4 circuits, 250. I would like if everyone can do the same. Your first circuit has how many sockets, and give it a value. So if I want to do the total, I will just take 4.
Sorry, before this is 254
is the nominal value for each socket. You see my circuit here is having four sockets.
Yeah.
Yes.
Nominal voltage or nominal
Power. In average, they give to each socket 250 watts when you're doing calculation, because you don't know which type of equipment will be plugged there.
Oh, that's what I want to understand. How many watts you make approximately in each socket?
How many?
How many? You mean 250 watts in each socket?
For calculation purpose, we give to each socket a power of 250 watts.
Oh, okay, understand. That's what I want to know.
Yes,
okay,
my first circuit has a 4 socket. I've called it PCG1. My second circuit is having 1, 2, 3, 4, 5 sockets. You can see here. It's called PCG2. It's having 5 sockets, 250, which is 1,250. My fourth circuit, my third, sorry.
Okay, so engineer, may I ask you?
Yes.
We can't exactly approximate the power, because we know this the capacity of this DP switch, because the protection device on this DP switch. Maybe they are using.
We are not yet on DP switch. We are still on single socket.
I mean, even this socket, we have their protection. They have fuse. We know their ampere and we know the low voltage. So we can't approximate maybe for this socket having 13 amps, how much load they are going to take maximum.
The protection.
We can do that.
Who is talking?
Rama.
Is Rama talking?
Yes.
Yeah. You size the circuit based on the power. No, not the other way.
You
start first by what are you plugging on a socket, not on the protection. The protection will come after.
What I'm saying, you say you approximate this socket.
We approximate. In the calculation, the standard says give 250 to each socket.
But we know the rating amps for this socket.
We don't know, because you can plug there a phone, you can plug a computer, you can plug a radio. It's up to
Okay. Proceed.
For the DP switch, where we know exactly which equipment will be connected then we can put the exact measurement. But for random socket, the standard says you put 250 for calculation purpose. Okay. So I have the third circuit. It has 4 sockets, as you can see here. Then I have the fourth circuit is having only 3. having 3 sockets, which is 750. So if I go now to the 5th circuit, the DP switch for the AC in the dining room, it is only one equipment up to the last one. The capacity, it is the AC machine that we put on this calculation. We have 5,000. We have the next circuit is PCG6. It also have 5,000. Sorry. It also have 5,000. We have PCG7, the 7th circuit. This one here, it is the hand dryer. For the hand dryer, we have 3,000. We have PCG8. Should be somewhere. Let me check. Yes, 8 in the bedroom. It's also having the capacity of the AC machine. And we have now the last equipment, which is the cooking machine. It has an isolator, and the capacity of it, we can just go for a 3,500 cooker machine. So we have it here. It is 3,500. So this is the total number of circuits or equipment that we have in a DB ground floor. So all of these are on one DB ground floor. Any question? Someone has a question? Yes, boss. Sorry? 250 is the nominal power when you are doing calculation. For general purpose socket, general purpose, yes, because it's just like this socket here. You don't know which type of equipment will be plugged there. It could be a projector, it could be a telephone, it could be a computer. So generally by standard they say put 250 because it is in average one of the maximum capacity of simple equipment that you can plug on a socket. So computers, radios, all these small machines, they're always below that value. Yeah. And in case they will one day put a bigger machine there, what also helps us to make sure we are not beyond the value is because we cannot plug big equipment on all the sockets on the same circuit at once. Let's say the time we are plugging this projector, how much does it have in terms of power? Maybe it's consuming a lot, but all the sockets in this room are not plugged at the same time. You see, some are free now, so some can be overloaded while other are having some power. And you see the protection of this circuit will be very far beyond this value, because in a nominal situation, the protection of the power circuit is 16 or 20 amps. 20 amps, it is something around 4 kilowatts. So regardless of what you can plug on those sockets, the power is still below the acceptable range. Let me just check. 20 amps times 230. You have 4.6 watt. Yes. Of what? Yeah, but you're not yet there. I said this was a template. We are still focusing on this DB. When we finish, we'll go for the second DB, third DB. All these will be deleted because these are for a previous project. All these will be deleted because they are for a previous project. Then we will do a new calculation here down. Yes. So for now, ask me questions about here. We have 4 circuits of light, which are these ones. Then we have these 9 circuits for power, which are these ones that will help us to do the next calculation. And these are my circuit for first floor. These are my circuit for second floor. I'm going to add light here, light here. I will delete all of this and go for the total calculations as we are expecting. Yeah. Guys, can we please finish ground floor? I'm just keeping these for reference. I know there are some time I will need to use them, but when I finish, I will delete them. If you have any question, please ask it now. This is special load 3-phase. You know what we'll do? Using mine. I don't see yours now. Sorry? What is your size? We want calculation. You don't have to say anything. You can close mine.
Yes, Engineer Tucker.
Use the copy. You don't use the copy.
Hello. 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 Hello.
I think he's far away from his computer.
Okay, Mr. W, you can help to send my message. You know, today is a Friday. I need to go for prayer preparation, so I will join back at 2 p.m. So you can help me to send my message to them.
Okay.
Yeah, because now it's almost 12:30, so we need to go for preparations. But 2 p.m. I'll be back. So can you help me to send my message to him?
Okay, I will send.
Oh, thanks.
I mean, for now, what are we going to practice?
We are I wish I could have seen your screen. Did you create your own file, copying mine, and you do your own calculations based on your circuit?
I have already created mine, but I was watching you teaching.
I've finished long time. You have also now to adapt my template to your circuit.
Oh, okay.
Were you just closing hands waiting me?
I was just practicing what you were doing.
No, you now do it on your file, based on how your circuits are arranged. And if you want to get reference from my files are shared on the drive. I've shared them in the morning. Can you share your screen? Guys, please, let's push, please.
Also, Mr. Ram has requested to go to the prayer for 1 hour.
My friend, share your screen.
Okay.
Recording in progress.
You can't see your screen yet?
This is my
Is this your file or my file?
This is my.
What is your name?
Here.
Okay, say adapt it then with with your circuit. Do you have 9 circuits like me for power?
See, you are. I was entering your details of the first floor.
But we don't have
Of
same
the
drawing.
ground floor.
We don't have same drawings. Me, I have
Okay.
9 circuits of power. Do yours also. How many circuits do you have for power?
Okay, let me check.
On your drawing, how many circuits do you have for power?
I have 4.
You don't have DP switches.
I have.
How do you have 4? DP switches each has its own circuit.
Oh, okay. This is first floor.
Hope people are having their power drawings well arranged. Hope people have their power drawings well arranged with DB location, with circuit and names. I need it before you go for lunch, please. Yes, if you have internet. It is a shared document. You don't need to save it. If you're connected, it saves automatically. Priority is always the drawing. If these calculations are too hard for you, leave them. Priority, finish the drawing. Okay? Oh, so here. Priority, maliza drawing first. Calculation, unaweza kuendelesha nyuma. So submit ya kwanza ni drawing. Power, fire alarm na light. So here, don't spend too much time on this. Make sure your drawings are finished. Title block, everything. Print, send. Before lunch. In 6 minutes. Hey. You do it. Focus on drawing. Focus on drawing. Light for second dB. It should come from your drawing. Light first floor. Sorry? Copy how? You don't have a design. Light first floor. Make circuit for light first floor. Sorry? Yes, then go for the same go for the same process. Add more lines down there. Whose presentation is this? Is it mine? Gabriel.
Yeah.
Are you the one presenting?
Yes.
But we are not seeing any progress.
I'm dealing with the drawings.
What about the table?
I was entering power those details.
Okay. Can you connect and share your screen?
Table.
Let's follow this guy because his recording will help people. Just do stuff as you are.
So I can stop sharing.
I think you're using the template slide, right?
Okay, so we've done the ground floor plotting. Going for the first floor, also done. So we're finishing the lighting. Go second floor, the main bedroom, bathroom, and another bedroom. So for the arrangement of the luminaires, after getting all of the information, we measure the distance for the width, and we'll go and measure the distance for the length. Then you divide the whole rectangle or square. We choose to divide it by 4. Say 2.7 divided by 4, you get 0.67. Let's take 0.68. So we disable the snap cursor. 0.68 again. Then 0.68. then let's finish on the other side. It's like 2.3, 2.4. 5 divided by 4. 0.6. Divide again. So here for the bathroom, just go to the first floor. What did you use for the bathroom? Downlights. So say copy and come here and paste for the arrangement. So after doing your calculation, you will know how many lights you're supposed to put in the room. So for instance, if you get 4, then you place it, let's disable this. You place one here, another one here, another one here, another one here. But say you get 3, you can place 1, 2, and 3. Okay, so that's 3. There you go for the placement. 1. Here, another one here. And the third one over here. This is just to help you to organize the light, because you need the uniformity. You don't need one part of the room very dim and another part very luminous. Then you can just delete the boundaries. Now we remain the 2 remaining bedrooms. I will come again, dimension, linear. You measure the dimension. The luminaires you already have. You just calculate the area to see how many lights you are supposed to put in a room. So after finishing that, uploading the light, then you finish from the load calculation there. Just as we did for the power, in order to finish everything. You go 2.95 divided by 4 get 0.74. And now for the width, 2.2 divided by 4 we get 0.6 or 0.55, whichever one you choose. So yes, we already divided the room. To check for the area, you just go to properties, and then highlight your square that you made. You can see the area here, 6.5. So according to the lumen, you go to the formula and calculate how many lights are required, and then just plot. Since I've already done the calculation, I can just continue the plotting. Let's say using the same luminaire. Second floor. Continue the placing. The next one. Maybe no budget. Okay, now cursor. And then you go and move it. And then the last one. Over there. Now I can just delete the boundaries. Then I remain the last one. To get an approximation of the room, you can just go from what's the diagram, this one, on the PDF. I can show you here where the boundaries, and then I can follow from the drawing there on how you draw your rectangle. This is the area. Then use the same luminaires. After you've done a calculation, you get how many luminaires are supposed to put there. And then I just proceed with the boundaries. So for instance, this you have a luminaire of 1200. So the area we know is 8.6. Then you go to properties and check the area 8.6. So luminaire for lux required for the bedroom is 300. So you take a 300 times 8.6 with the area divided by 1200, the value of F for the light, and then multiply by uniformity factor, which is a constant at 0.8, multiply by maintenance factor. It will give you 3.16 something. So you know, luminaires required for this room is also 3. So again, you go for the dimensions. I'll help you organize things. And then you take, say, 3 divided by 4, it's 0.75. Then you go ahead and activate this one to give you a straight line, but then disable the snap cursor. And you're drawing the bound after the first boundary. So again, 0.75. Again, 0.75. Okay, now finish the plane. Now we go for the width. Activate snap cursor. And then take 2.8 divided by 4. You get 0.7 exact. So activate snap cursor. Again 0.7. Again 0.7. So now you are done. You take your light. Four. Nimalizie kazi nyingi nyingi. Lazima umalize utoke uweke fresh. Okay, so delete the grid and the spaces after using it for it to look neat. Then don't forget to add the appropriate type of switches, whether it's manual control, movement sensor, or dimming switch. So just take from the diagram that we finished. Bedroom, we have a dimming switch. We just copy everything. And then we come, where's the bedroom? Here. Where is the access from the bedroom? From over here, so we install it near a wall, like this. You want to keep it neat, just rotate it. Right click, go to rotate. Keep it however you like it. Move. So this switch will will be responsible for switching all of the lights in the bedroom. And then we go to another bedroom. Again, dimming switch. Yeah, let's put it over here. Just for the sake of understanding. Let's say rotate like that. Then where's the other bedroom? This one. So there goes the door. Let's keep it somewhere here. Rotate it. Bring that. Move. Like that. So you repeat like that. The circuit, the same. You start from the switch, you connect luminaires, and then since it's just the lights, they won't have a lot of load, so you connect two circuits together like that and form one circuit for the breaker. Going for the break.
Gabriel,
Yes.
did you finish power?
To print or to design?
Finish design.
Yes, it is sent yesterday.
Okay, so Filam also is finished.
Yes, I'm sending right now. It's finished for design.
You say your name is? This one. And the three are here. Right. Oh. Yes. Hmm? Okay. Nashobora gutegereza iminota 20. Okay. Are you done also with this one? You are done with this? Okay. Lukman, how far you? The first, okay. Omar, I'm only seeing power here. No. Only power. Okay, I can see it. I can see it. All the three. I'm seeing only two. Ground and second. There is no first. Side? Full side? How far are you? I'm seeing here power. I'm seeing here fire alarm, the 3. I'm seeing power. What is light? Print first and second. Yes. Almas. Who is Almas? Eh? Who is Almas? The guy who went outside. Eh? Haya nayo zote 3. Ana mix vitu. Copy. What? Ali ni nani? Who is Ali? Manyundo. Is empty. Sorry? The virtual person. His self is empty. Bryson. Sangi. What did you post so far? Yes. Hii ni mambo ya siku gani? Ya jana? Haina circuit. Emmanuel. Your folder is empty. Gabriel.
Yes.
I'm seeing power, fire alarm. Fire alarm of which day? Ground and ground first.
Ground and first.
I'm seeing floor plan. I'm seeing ground first and ground floor. And your title block does not have information. There are no information in your title block.
I forgot to put the information.
There is no drawing name. I've shared with you my drawings in the morning for you to take reference from it. You want to take a picture? Unakataa joining. Jervas. Fire alarm of yesterday. Can I trust it? Should I open it? Eh? I told you focus on the design. Title block haiko mambo ya kufanya focus now. Eh? Who is not here? I think he's here. Hey, Papa. Rama, where is your files? Rama.
I didn't send any file to you because you told me to focus on design, so I'm finalizing.
You're focusing on design. That's why you're not sending me anything. You don't even have a folder.
Yes, I'm finalizing what you told me to make at the morning for the ground floor for socket, power, and the lighting. So when I finalize, I can make it in AutoCAD, then I can send to you.
Wait. Sorry. I was saying for people online, we are going to go up to the end of the design with the plan of our friend Sharif, who has made it until the end of this project. This is also a proof of his dedication, because I've told you, spare time in the night to work on this. You can't finish all these projects working from the office, because there are many aspects that need your time to go through slow by slow, apart from here. So we have the light. This is first floor. This is first floor or ground floor? This is ground floor. Yeah. So we have ground floor. We have this. Then we have the normal socket. I'm going to just keep one line between them. So these are his normal socket. Sorry, socket side. He has 3 circuits, or how many are these? He have 5 normal circuits, and he has everywhere you see 5,000 is AC, and where you see 3,500 is a cooker. Where is the one for the hand dryer? So the one for hand dryer is 300, is 3,000. You forgot it. Or you made it 5,000 instead of 3,000. Can you open the drawing? Can you open your power drawing? So this is this is light power. What is light for? This is light for first floor. There are only 2 circuits. Okay. Also, he has 2 circuits for light on first floor. These are your sockets for first floor. These are your sockets for third floor. Sorry.
Okay.
What is this for? You don't know this one. You know these ones. I can remove them. What about this? These are yours?
I know.
These are yours. What about this?
Yeah.
These are also mine. No, these 2 is me. And the one here below, they are not yours. Alright. So the person who was asking, what is this for? We are now cleaning. And even remove this also. Let me keep them just for now. So this is ground floor up to here. Let me make a color. This is ground floor. This one also you don't know. Okay. That is ground floor. This is first floor. Not visible. That is first floor. This also we delete. And this is second floor. Okay. Also 2 circuits for light. Yes. So we make it green. We delete this one. We have it. So the first thing is to make sure we have final power everywhere. I'm going to check his drawing to see if we have areas where we have DP switch in the toilet. It means those one will be on 3000, sorry. So circuit 9 on ground floor is 3000 because it is on the DP switch of the toilet. So I think first floor does not have any toilet, so all the DP will be 5000. It has okay, so that is circuit 5. Circuit 5 on second floor, sorry, on first floor is also 3. And we go on second floor. Circuit 9 and 8 are also 3000. So I hope up to now things are clear. We have the total power for all the lights. We have the total power for all the power. We have all the total power. Sorry, we have all the total power for normal power and also for a cooking machine. So what we do now, after having the total, the next step is to attribute the phases. Like each single phase should be put either on 1, 2, or 3. That will be the idea. So let's say, for example, if we are having here 3 circuits, and all of them are having a cross value, just 1, 2, 3 here. For power, 1, 2, 3, 1, 2.
Mr. Taka, if you're using the screen, please share.
You're not seeing the screen all this time. I'm sorry. Are you able to see the screen now?
Yes.
So what we are doing, we just first make sure we have the total power of each circuit, which you can see here, and then trying to allocate for each circuit where is it going. So you see how we did it. The 3 circuits on ground floor are one on first circuit, another one on second circuit, the third one on third circuit, and we are doing it for power. I'm just doing it randomly like this, but at the end I was saying I'm just putting it randomly here, but at the end we do total. When we see there is a big balance, we can change. Let's say take this from first circuit, let's put it on 2, so we can achieve the balancing. But here we just put it. It's not like you are putting it randomly to give this 1, this 3, this 2. Have some logic, but at the end we'll see first circuit has this total, second circuit has this total. Then we can see if there is a way of taking a circuit from first circuit to put it on to take a load from first circuit to put it on second circuit, so we can achieve the balancing. So here I'm putting this on 1, I'm putting this on 2, I'm putting this on 3, and I'm putting this on 1. Sorry, this is a 3-phase equipment. It doesn't even need to be attributed the circuit because it will be on all of them. So I just write 1, 2, 3. So when I come back here, I put this on 1, this on 2, the first phase for power on 3, this on 1, this on 2, this on 3, this on 1, 2, 3, 1, 2, then we come here, 1, sorry, equal by 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So as you can see here, we have already attributed all the power to different circuits. The next step we can do is to calculate the current. So this will help us to know which protection can we make for each point. So as all these points are sorry, this last one also is 1, 2, 3 because it is a cooker. It is 1, 2, 2, 3. I think we are all following. So what we do, all are single phase points except the one which are the three phase. So what we'll do, the result here, we'll do the total power divided by the level of voltage. People who are busy in their computers, are they following what I'm explaining? Let me repeat. Oh, up to now, who has a question? Who has a question? Something which is not clear for him. Boss, is it clear? Can you repeat what I said? What are we doing? We are balancing. Okay. So can you explain me this column? What is this about? J. What is J about? This one. This column. To represent what? So we're going to calculate the current after having the total power on each circuit. We're going to calculate the current. What I said, that's why by default we are putting the voltage between two phases in from phase and neutral here, because when we calculate the current, you will be able to, you can set this quantity. Let's say if it's now 220, you can change it and it will affect all the result here down. So what we are doing, we do calculation of current, which is power divided by voltage. We take this value here, 77, we divide by 230. So we have 0.77 3. Same here, we do this divided by d4. We have this value. We have this divided by d4. We have 0.8. You see, when we start doing power circuit, we'll have some interesting values. We do equal this one divided by d4. Have this one divided by d4. Have this one divided by d4. Let's see what 5000 is going to give us. We have 21 amps. Have this one divided by d4. 21 also. So this one normally will be equal to this value. You know the calculation of current in a 3-phase. 1.73 times the double the voltage line by line. We have only 5 amps. See? We do the same for first floor. Hope you guys can also do the same in your computers as I'm finishing. So this one will be the same as this one. So this is the 3. Now this has the same logic. D4. We see we have got the current on first first floor before and take it like this, delete this one, change 4 4 4 4 4 4 4 4 4 4. Cool man, hope you are doing this. Look man, cool man. So we are going to take this also. Soon. 5 sharp. 5 p.m. sharp. You want to chase us here? So this is D3. So also 5. Clear up to now? Tunasikia? Tumemaliza kufanya power, tunafanya sasa arms. Kwa sababu mfano hapo unaona hii imefika kwa 21. Tukipatia breaker tunapaswa kutoa breaker ya juu. Kwa sababu kwenye sub imetupatia 21 arms. Tukipatia breaker ni breaker za juu. That was the purpose of calculating this. So for the person who asked me about this one now, yes, both. That's why I've asked, do you understand the meaning of this G column? G, yes. Yes. Do you understand the meaning? Let me open the drawing of this guy. Tarif for our first floor. It means J means LCG1. Let me take the one for power because I did not open light. This circuit is called PCG1. PCG1 on the drawing of this guy. This is first floor. It means PCG1 is this circuit. It has 4 sockets, it has 5 sockets. That's why he put 5 here. Each socket is having 250 watts. The total is 1250. It is on circuit 1. And when you divide with the voltage rating, which is 230, you're getting 5 amps. So the current which will cross in this circuit is 5 amps. Yes. Same with the next point and the other one and another one. So these are the total power on each circuit. And all those circuits are here. From 1 to 10. 10 is this one here. This last one is 10. Second, ground floor, first floor, second floor. Is it clear? Wattages. Each normal socket is having 250. Yes. 250 watts, that's the power. Sorry? Voltage is the voltage of the network provided then the supplier. In Tanzania, between phase and neutral, there is 230. Yes. Okay. It is good. So what we have here, we now have what we say load type description, lighting here. It is putting the total load which is connected on lighting. Okay, how much do you have connected to the lighting? We will take the summation of all the values. Hope people are following me. So we have these 3 circuits. Lokman, please follow. We have this 2, and we have these 2. The total power of all the lights in our entire project is 1139. Okay, we have the total load for single phase equipment. The total load for single phase equipment for us is it will be the summation of all the power except the one for 3 phase. We have this one here, have all this, have all this, and we have all this up to here. So it is 8,600, 86,500. Total load of 3 phase. We have this one and this one on ground floor. There are 2. Sorry. Would be this plus this 7,000. So what we can do, we can say total power on phase 1. We insert other 2, sorry, below, sorry, total power in phase 2, total power in phase 3. Total power in phase 2, sorry, in phase 1 will be equal to all the load which are connected on phase 1. That means we have the summation of starting from here, sorry, here we have, sorry, we have this one, we have this one, we have this one, we have this one. That's all for single phase. On ground floor, first floor, we have this one, 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 I have this one. We have 26.6 kilowatt. Sorry? Yes. Yes, because for phase balance, I have to check. I have to make sure the I'm calculating the total power which are on phase 1. Yes. For second phase, same process. We do this one, 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 we do. People online, are we together? We're
Yes.
just summing all the power that we allocate on second circuit.
Okay.
Hope this is very clear and easy. I have this one. So this is phase 3, phase 3, phase 3, phase 3, phase 3. This should be removed. The 41 should be removed. Should be removed. G45, G48, G58, this one, and remove this one because this is common, it's shared. Okay, for the person who has asked me about load balancing, I'm responding to you guys on phones. Eyo. I'm responding to your question now. We have the total power on all the 3 circuits. What is missing is to add on them the contribution of the 2 3-phase points. This one, because this one is distributed on 1, 2, 3. What we did here was the summation of all the single phase. So we can say this is total power on phase 1. You can call it total power, total single phase. Phase power on phase 1. I think this is clear. Is total single phase power on phase 1. It means all the single phase equipment that are connected on phase 1. So what we can do now, the same now, we now call it total power. Total power, connected on phase 1. So that will include even the three-phase equipment. So total power connected on phase 1 up to total power connected to phase 3. Sorry? Yes. What I will do when I'm doing installation, I will just bring all these circuit as they are named like this here, the DB. Then I will know LCF1 is on first phase. I'll put it on first phase. Because this, I think this you can know, right? This one we can get it in the building, right? Because this guy has a drawing of a lighting circuit which is called LCF1. Because each apartment is supplied by three phases. All the phases that are on first circuit, we put them on first circuit. If you want, we can bring it to the RS. You call it RST. How do you call the three-phase system in terms of names? You say RST. That's how we call it. So you call it RBY. It means where I'm saying phase 1 is all the R, which circuit are going to go to R. The second circuit, all the circuits that are going to go to B, and the third circuit are the ones that are going to Y. We said if you are having three-phase equipment in your building, then you must be supplied by three-phase. Because you can't run a three-phase equipment on single phase. That is the fact. It means whatever small is your building, if you have an equipment that is running on three-phase, you need to request for three-phase supply. That's the first one. The second one, we said, when you have a big load, let's say like this hotel, it's an example. It depends on the range. If it is having a big load and it is on the single phase, you know it is going to concentrate only on one phase in the grid. That grid will be having a high voltage drop because it is connected on someone who is having a big load. You know, even in these like, okay, the way maybe your systems are here, like in Rwanda, people are supplied by single phase only. For us, you might be supplied by three phase, then you choose one of them. You know what is there? When you see one phase going down, like is having bad quality, you shift to another one. When that one is not good, you shift to the third one. So the problem is like this guy, the phase is having, or if it is having single phase supply, and that specific phase, because it's a big consumer, it will be always having a problem because it has one person who is taking a big load. It is okay. We are first seeing that in that way. What it can also bring is the issue of the load and balancing in the transformer. Because maybe, let's say this person is consuming 50 kilowatts. It's an example. Even if he has only single phase equipment, but it's 50 kilowatts. Let's say the total grid that we have, with plus all the other consumers, which is other consumers are 25. Okay? So let's say other consumers are 100. And we have maybe a transformer of 185 kilowatts, or kVA, whatever. Okay? So this guy, from this, we say DOI, this is first was what? this hotel is consuming 50 kilowatts. Okay? Distribution of 100 kilowatts, let's say here there is 40, here there is 40, and the other 20 is here. Okay? So it becomes 70. It means the total one, here there is 40, there is 40, and there is 70 here. Normally, this is a difference transformer. It means the aim would be, let's say at least to have here 60, 65. At least if the load could be balanced like this. So, let's go with it. I'm waiting. I'm waiting. I can go there and talk from. Okay. So, if we could have 60, 60, and 65, it could be better. But you see, because of this big load, only this one is having 70, while other are having smaller. Okay? So we will observe a very high voltage drop on this surface where there is a big load. So that's why I advise this guy, you go 3 phase. And make sure you're balancing your surface the way you put them there. Why? Because regardless of what you consume, there will be distributed to the surface from the grid to avoid having a high voltage drop in one of them. So depends on the standard of each country, there is a level of power. When you come to protect your house, to give you a supply, they say if your power consumption, the way you give there, you have to request for different system. Yourself they oblige you, because if you connect single phase on this system, you experience the drop, voltage drop of one of the phase, which will affect also the other, because it's a different transformer. It aims to have load meter balance.
But if attachment to either they don't need single phase. But you have one machine that is use 3 phase.
Yes.
That's what you
Can replace it, or so sometimes you can do a special request of 3 phase. Depends on what you have as a load. But mostly for commercial buildings, most of the time, kitchen, you have to operate every time. The load is always high with all these ACs. Then you are obliged to go for 3 phase. So like there is a 3 phase you request a load because of what you have as equipment. You can be a small bakery business and you have 3 phase equipment. You can go to request for a 3 phase system because of your machine. And sometimes it's the government obliging you to go for 3 phase because of what I explained there. So here there are people who have brought us some wine. Wine is getting cold. David, what can you do? You're not yet done, unfortunately. But if we do the ceremony, then we push. Give me 5 to finish this chapter. We'll close it. Then I'll be doing something as you are doing your stuff. Then before we leave, I'll present something, and then we'll finish. Let me finish this chapter. Then I'll. Yes. Okay. I think this is very clear. So, one of the way to check if your calculations are right, normally, if I'm not mistaken, this total load should be equal to this, right? Am I wrong? Fullman. That the total load of single phases should be equal to this total load. Okay. Let's see. $82. There is a 300 missing somewhere. I'm saying this total should be equal to this. There is a 300 missing somewhere. This is 500, this is 200. Yeah. Let's see.
Mr. Tucker. Mr.
Yes,
Tucker.
boss. Yes, boss.
Sorry, may I ask you questions? I see this is a 3-story buildings. You are doing this sheet. If maybe you have 15-story building, which maybe they have apartment, office, and others. By using this sheet, we can use single, or you can block with maybe 5-4, then you can take it in, or you can make one sheet to do all buildings.
Yes, there is a person asking if we have many floors, like let's say 50. 50. He's saying, what if we have a 50-story building? Should we bring? You're asking if we should bring the 3-phase connections to all the floors? Is that your question?
No, I mean the method of calculating total load by using this sheet. I see if you have many buildings, the sheet will be too big.
Yes.
That's why I'm asking you.
Is there any problem with having? Is there any problem with having? Is there any problem with having a long sheet?
That's why I'm asking, because it seems to coordinate something.
You think there is a problem with? Yeah, I will show you a single line diagram of our DD. There is no problem with having long things, unless you think it will be misleading. Something's wrong. Ah. But this is getting bigger. Okay. Let me see. We should have added also this, but the value is getting bigger. Is 3. So this will be G what? G23 to 25, then enter. Oh. Guys, leaving me alone. We started this together. You're leaving me alone. Eh? You withdraw. So this is the total power now. Did we forget something somewhere? Ah, for this also. Ah, no, I'm confusing things. This is total for power. Yes. So this is light. I delete it. This is power. Okay. Then normally this should be this one plus now what I was saying. Saying this should be the total. This is the total here, okay?
So we take a 3 phase, that is for
Yeah.
power.
So this is single phase for power. This is light, and this the total are everything. Okay. All man has left me. No problem. You can't see. We are trying to check if we are correct. This is total for light. Okay. This is total for power. And now if we calculate total connected on single phase, get this one. Normally this should be equal to this. Sorry, this should be equal to this plus this. Isn't it? So they should be equal. Normally should be equal to this one. Yes. So I'm wondering where is the error. No, should not miss anything. Should be equal. These are total power on single phase. Should be equal to this plus this one. Let me see the difference. There is a 1,422 missing. Boss, are you following? Oh, you're just waiting for certificate. So this is power. Then this one, light, this one plus this one plus this one. Why they should be equal? Or maybe we took one value twice. Or we forgot maybe. This is phase 1. Are you seeing something there which is not on phase 1? Nothing. Something on phase 2? Something on phase 2 which is not there? This one. Missing. And you see, it is 1, 2. Or is this one? There might be 2 missing. This one is there. This one is missing. G42. G42. Now there is a miss of 172. Where is it? Detect it. This one. Fullman is lost. Tell me to zoom it for you. I've seen it. And I'm happy. Now I can go to sleep. To Kariako. Guys, we found it. Now they can give me a certificate also. Eh? No, there were value missing. This 172 was missing. Now we got it. So now I deserve a certificate. This G4353. G is here. G53. See? 0. Eh? Kawaida. Those people are learning. They are learning. We're still learning. And I will be asking questions to people before they get certificate. So that we are done. Sorry? What else do you need then? I've finished. Eh? All the proof I provided. Eh? Things are balancing. Now, last thing. Total load on first phase will be equal to this one. Okay? Will be equal to this one plus this 7,000 divided by 3. You know why? Eh? This is the total number of 3-phase equipment. To get the total power connected on phase 1, you take this total power on phase 1 single phase plus the third of the total power of 3-phase. Is the fan of this guy? You don't see his name. He will give you. Yes. So you get this one. Is equal to this one plus this divided by 3. by 3. The next one is this one, plus this one plus this divided by 3. Something else, last one, before they give us certificate. Normally, this total should be equal to this total. Does that make sense? This total should be equal to this total. Equal to this plus this 93,500 should be equal to this sum. $83, this is D. Complete. Ah, okay, 2 by 3 divided by 3. Cool, man. Leaving me, man. A small last item is we are just this is now equal. Okay, 7,000, 7,000, 9,000. This is this. Let me remove this. Can we add the total power of single phase of the one for 3 phase? To get the total, it's tricky. Can't do it. Because I've added the total power for single phase of the one of 3 phase to get the total power that we have. It should be this one. Okay, both. David, floor is yours. So I was saying, thank you for people who came to attend this training. And I was just emphasizing that being an employee of life and family sometimes makes things harder when targeting to achieve mostly a training like this one for full time. It requires people to come here from morning to evening. So I wish was like if people could have spent some more extra time in the evening to repeat or to catch up on what we were pushing, it would have been better. So what I wanted to say is you can't master software in 1 week. It's impossible. Even me, who have been in this since all this time, more than 7 years, I'm still learning. So even AutoCAD is making it that way, because when a new version of the software comes, you have to update yourself because it comes with different new features. So you can't say people who did AutoCAD 2010, maybe even a person who is learning AutoCAD from YouTube is better than him, because that guy is all those old time, like a lot of things have changed. So to say, when you enter in this field, you have to update yourself each and every day. People who have been sent to the training maybe by their companies, please take benefit from this and use it usefully, because when you get even a project aside, it will be for your interest. So you have or you must push to master this software and understand the process. What we did was to give you the basics for you to be able to continue the learning process yourself. Because from the experience of the software, when you start from like scratch, and you don't have someone to guide you, is tricky for you to progress, because there are some barriers that need you first to understand before you proceed with your self teaching. Like if the next version of AutoCAD will come 2026, I will navigate it easily because I had 2024, I have 2025, and the new one is coming with maybe 2 or 3 new features, and I will navigate them easily. So have that spirit of learning, updating yourself every day. These software field, they are very profitable. Why? I will give you an example. There is a time I'm called, because in Rwanda there is what we call a working permit. Sorry, there's construction permit. Like someone wants to build the house and they need a construction permit. We have to include all the drawings. I can sit for 3, 4, 5 hours if I'm very fast, do a drawing, and I'm paid more than 100. It's just a simple work. Why? Because many people are not able to achieve the same level of details. So people have made the drawings with their best quality or with their best capacity, but I aim that if you find yourself that let me check with what I did and what I did, I'm seeing a big difference, aim to go for that way and improve the quality of your drawing. So this market of software is booming, and we never lose to invest in education. You invest $20, you get maybe 5, 10, or 20 times what you invested. So they take this as an opportunity of keep learning about
AutoCAD, master it, and be beneficial for the society and you alone. Something else, what pushes me also to come here, regardless of all the activities or tasks that I have to do, is meeting new people. Meeting new people, sharing ideas, creating a network. Yes, I'm the facilitator here in front of you, but there are people who are senior or having more responsibilities than me where they're working. And maybe there will be an opportunity. I will need to come to Tanzania next time for something else. And Lukman will be now a friend or a brother who was before just a student. So this was an opportunity also for me to discover this place. Unfortunately, I didn't have a lot of time to move around because every time I went back home, I had to rest and continue preparing the course, and also my responsibilities back where I'm working. I had to report and work in the whole night. Actually, I didn't have time to discover the area, but I wish I could have gone around and see many areas and talk to people, meet people. I really like that. So that is my summary. To make it short, I hope that we did the best we could, and a few other small items that are remaining. We are still together. The WhatsApp group is there active. All the materials will be sent. Even beyond the training time, if you still have a challenge or question, just put it there. And if I'm not responding to you, just talk to my boss. We know how to address me. Eh? If you're asking me a question, it's delayed. Just talk to him. Say, I need Taka. There's a clarification I want to get from him. He's not responding. Maybe you call me to another number. You know how to talk to me and provide you support. So let's have that culture of keeping learning. Open your mind for new items, meet people, discuss, and everything will be all right. So what maybe we had to finish with was the single line diagram and the material specification. Material specification is not a big deal because it's only items we had that now we need to, like if you go to the market now, what are you going to buy? Which breaker, which line? Just in terms of giving the name of the item and all the description, so we can be able to order online, maybe sending it to a manufacturer to provide it to you. So the only critical item that we had to do was the single line diagram, and we did it. What remains is only to draw it on a circuit, which I can still prepare and deliver. But the hardest things was to do load calculation, all the load balancing plan. We did it and we are finished. Yeah. Thank you. Sorry? Sorry?
Yes, I also wanted to mention, while he's still concluding, we have upcoming electrical control and system trainings. You know, these are for buildings. So we have the other for controls systems. So we also invite you to enroll with it. It's going to happen in May. So whoever thinks like he's interested, feel free to pass by me, and then can put you on the list so that next time it will be easy for us to remind you and for you to be reminded. Thank you.
Yeah, so I'm going to emphasize on something, but to finalize this discussion about the importance of investing into education or in learning. I have an experience. When I was working like two years ago in a company where we worked from Monday to Friday. Now it's tricky because I'm sometimes even working on Sunday because it's site work and it has a lot of challenges. So the culture in our company was Monday to Friday. Saturday, Sunday is chilling. People are going to the swimming pools, like hanging with the family. Yeah, he said, let me focus this time and go for another master's. So I had another master's for renewable energy I now went to a master's for an MBA, business and administration, for an engineer to get the management side of things, like to get that side of skills. We learned some financials, human resource, like these things that people are doing, managers are doing. And up to now, I'm not yet even done. I'm just writing my book about energy access in rural areas. But from that degree, where I've spent now almost around where I've spent now around it should be around 2.2 million Rwandan francs, which is around 1.8 thousand, like $1,800 and time to go there. I'm now a consultant. I'm now a consultant because I can deliver both, like most of projects, they have both aspects of engineering and management. If they tell you go and do assessment of a project maybe in a rural area, you're not going there only with engineering skills, with measuring the distance and whatever. You have to assess the socio-economical aspect of people and whatever. So it also gives you, it also requires you to have those side of things. They're going to tell you to do financial analysis of your project. Yes, you can hire a specialist, but you still need to understand what that specialist is doing in that side. So for the last 2 years where I've invested my time and money in that, I'm now getting, and I know when I'll get the degree, I can get more than that. So it means we should not neglect these opportunities of coming to learn. Many people are outside here, they have money, and they wish they could learn AutoCAD, but they don't have time. Maybe they're traveling, each 2 days they have to go and come back. So they can't sit somewhere for 3 days. This is still an opportunity. That's why even for young brothers to finish this, your young brothers or your son, your kids who are still finishing their secondary school or university, make them busy with trainings. Let them like grab everything. I've been in the bus. I'm just stopping from here. One time going from Congo to Rwanda and to Kigali, and I met someone in the bus who told me, whatever you find instructful, learn it. Well, even if you don't know where to bring it. Oh, I'm interested in karate and I have time. Each Saturday I can go there for 1 hour. Do it. There's where they're teaching guitar. Maybe I have that time and I need it. Learn guitar and keep it somewhere. They are driving car. I want to learn about it. Learn to drive it. Even if you don't have a car and you don't know where you use it. Because sometimes they will tell you should have a driving license to get this job. Everything is ready. Even the manager is your friend. But you have to provide a driving license. You will miss that job because you didn't have that driving license. So whatever you'll be able to learn with your free time or your possibility, please do it. And I wish you all the best and hope that we'll meet for other opportunities and share different other opportunities for the upcoming days. Thank you.
Thank you. So we requested some of you to help us with some of few interviews. Maybe we can record that and then we will teach the material. The material naming, right?
Single line diagram.
Yes. After like 10 minutes. Won't take 10 minutes. Okay, thank you. You can move on and move on.
People online are not hearing us, they don't talk. Fine. You don't know. I'll explain to you. Oh, I'll explain. Always on phone. So I have this is 8. 9. 9 and then 10. Yes, we have 10. So we need first to confirm the protection, because the current of circuit 6, 7 and 8 is beyond 16. Circuit 6, 7, 8. Circuit 6, 7, 8. You put 25. And 25. 25. 25. Okay, this is a 3-phase. I must. No problem. I will share. Definitely. Tomorrow at 7 a.m.
Tomorrow
At 7 a.m.
7 a.m.
Are you going to take me at the hotel to bring me to the airport?
No problem.
Yeah,
Yeah, sure.
Eh?
Yeah.
Now
We will have time so that
so let's call this total current phase 1. Then call this total phase 2. So here we can go this one, this plus this plus this plus this plus this divided by 3. Why is it too big? Yes, 33. This is equal to this plus this plus this plus this plus this divided by 3. So we have 23. This plus this. Yeah, so we have, you see, we have the 33, and this here is 40. Normally the nominal current of the breaker should be above the biggest value. After 40, we have 63. Means this breaker will be 63 breaker. Why? Because one of the phase is at 40 amps. Yeah, so this is normally the process we'll do for the same for the first floor, second floor, and we go for the same process here. Calculate the current, then we'll be able to to do what? To denote. What do you mean by denoting? The location, you put it in power. We had it. You mean this? Yes, we had it. This was my main DB location. Location on ground floor. Location on first floor, and location on second floor. Yeah. So guys, let's call it the training. Has been a big pleasure being with you for a week. Thank you for the support of everyone. I will put everything together and give you a final set. Sorry?